I will be discussing composition of functions. I'm going to talk about evaluating and using different operations. So the first thing that I would like to discuss is the notation that's used for identifying a function. Typically it's f of x, but it doesn't have to be f or x. It can be any variables. If you have a function within a function, as I stated in another video, that's referred to as a composite function. And so the way it could possibly look is f of g of x, where g of x is inside of f of x. So a function within a function. And another way that you might see this notated is f of g inside of its own set of parentheses, and then of x is in its own set of parentheses. This is an open circle. It's not a zero, it's not an O, and it represents the word of, just as the parentheses represent the word of. So again, f of g of x. That's how you say it. So I have a couple of examples that I want to go through. Pay attention to the directions because that will help you determine what you need to do. Evaluate in these examples simply means take what's given in your instructions and substitute it in for that variable. So the variable for my function in this example was a. So it's asking me in my directions, every time I see an a in the function, replace it with 0. So that's what we're going to do. And then you just simplify it down. 3 raised to the 2 times, and again, a is now 0 based on our directions, plus 1, and then we have a big plus 2. Once I simplify this, I have 3, and then 2 times 0 is 0 plus 1, so 3 is raised to the first power, plus a big 2, and finally 3 to the first power is simply 3. 3 plus 2 is 5. So for this example, when I evaluated W of A using 0, my outcome was 5. For example 2, I am still evaluating, but this time I'm replacing my n with an expression. So every time I see n in my function, I'm going to replace it with n plus 3 per the directions. -4, and also make it a habit of when you're replacing your variable, put it in parentheses, n plus 3 minus 2. And the reason you want to do that is because, like in this case, what I needed to do is to distribute this -4 to everything. But let's say I wrote it incorrectly and I just wrote -4 n plus 3 minus 2. That looks like something different. That tells me to combine those two, and that will be incorrect. So make sure you make a habit of keeping up with your parentheses. All right, so to the way that it's supposed to be written, once we simplify it, it is -4n minus 12, because -4 times 3. And then on the outside, I had -2. Well, now I can combine the -12 and the -2. And my final answer simplified is -4n minus 14. I do not try to factor or do anything else. This is it. That's when my directions ask me to evaluate. Sometimes I'll see directions that'll ask me to perform the indicated operation. When that's given to me, I'm going to have 2 or more functions given, and then I just follow the directions after the word find. So what are they asking me to do? They're asking me to add both the functions f of x and g of x. So again, there's more than one way to write these notations. So make sure you understand that. This f of x is just simply being added to the g of x. That's it. So another way, again, to say that is put f plus g in its own set of parentheses, and then x in its own set of parentheses, and then just complete the operation. So let's do that. We are going to take here x cubed minus 4, which is f of x. We're going to add it to 3x minus 2. Now, when I'm adding, I don't necessarily have to use parentheses. There's no reason to. Now I just want to look for like terms. I see that I have a -4 and a -2. So once I combine them and put everything in standard form, my final answer is x cubed plus 3x minus 6. No factoring needed. No other simplifying is necessary. In example 2, my directions ask me to find h of x minus g of x, which again can be written in a different notation. Pay attention to that so that you'll understand that. Okay, so now what I want to do is follow those directions. X minus 3 minus, well, this time, if you ever have a negative, you definitely want to use parentheses. So g of x is an expression, 3x plus 2. And the reason I definitely want to use the parentheses is because we should know that if you have a negative sign, then that means that you're going to distribute. So we wouldn't know that if we didn't put that set of parentheses there. Okay. So let's simplify this. And we have x minus 3 minus 3x minus 2. And again, I can combine some like terms here. So once I do that, my final answer is going to be negative 2x minus 5. Okay. Basic operations here. Example 3, I'm asked to multiply f of x times g of x. Again, this is another way of seeing it written out in your instructions so that we're just going to follow those directions. I personally like the box method. You can actually multiply them side by side if that's what you want to do. All right, so for me, I will set it up as, like I said, a box where the top portion of the box is going to have the x cubed minus 2x. It does not have to be in that order, but that's just what I'm doing. And then g of x is 4x plus 2. So I'm going to have 2 columns and 2 rows. And now I'm just going to multiply each row by both items in the column. And then I'm going to place it in the appropriate row. Okay. Hopefully that made sense. So for the first one, I have 4x times x cubed, which is 4x to the 4th. The next one is 4x times negative 2x, which is negative 8x squared. And then I go to the second row, 2 times x cubed, which is 2x cubed. And finally, 2 times negative 2x, which is negative 4x. Once I have my answers in my boxes, I'm going to put it in standard form, starting with the largest exponent. So I have 4x to the 4th, and then I'm going to go to the bottom left box, which is plus 2x cubed, because I'm looking at the exponents. And now I'm going to go to negative 8x squared, and then finally negative 4x. Again, I am not trying to simplify this any further. This is it. That's my final answer. So I put it in, I use the box method, you don't have to, and I put it in standard form for my final answer. Example 4, I am asked to divide. Now this one is not, so because you don't have to simplify it any further, you are literally taking f of a, which is a squared minus 5a, and you are literally dividing it by g of a, which is negative 2a plus 5. That's it. Okay. If I go down to example 5, I am asked to, now pay attention. A few minutes ago, we did multiply g of x times f of x, but this is different. This is saying take g times f and then replace the x with 2. So I have to do that for both. Another way that that would look is like that. So it might make more sense to you to write it out like that. So let's just follow the directions. I'm going to go up to g of, actually, let's see here. So for my g, I'm going to replace that x with 2 and then plus 1. So that's just going to give me 3. And now for my f, I'm going to replace my x with the 2. And again, I'm using parentheses. It will matter. There's a 2 there. And now once I simplify f of x, I have negative 4 minus 4 times 2 is 8. And this is negative 12. Well, my 2 answers were here. What I was asked to do is to take those answers and multiply them together. So that's what I'm going to do. So I have 3 times 12, negative 12. So my final answer, once I simplify it, is negative 36. Maybe I should have left those highlighted so you'll know. Okay, so I'm simply following these directions here. And then my last example. Now this time, this confuses people because a few minutes ago, we had a closed circle, which indicated we were multiplying, but this time we have that notation that means of. It's an open circle. Again, it means of. So f of g of x. And this will end in this example. So in this example, if I rewrite it, I can see it better. I only want to replace the g of n function with -3. So that's what I'm going to do first. Let's see here. So 3 times, and I'm going to replace that n with -3. I'm raising it to the second power minus 3. When I simplify this out, I end up with 3 times 9. Do not try to multiply this and then raise it to a power. That's not what that means. Okay, so, and a negative times a negative is always a positive. That's why it's a positive 9 minus 3. And once I combine or simplify, 27 minus 3 is 24. So this is my answer for the g of n portion. If I wanted to, so I'm not confused, I can rewrite that now as f of 24 because that's what the g of -3 actually resulted in. So now I'm going to take this f of 24 and I'm going to go to my function f of n and I'm going to replace that n with 24. So it will look like this, 2 times 24. And my final answer for the entire problem is 48. So I did want to go back here and say that, yes, this particular example is talking about multiplication, but it could also be any operation. It could be written as g plus f of 2, which again would actually mean replace your g function with 2 and then add it to your f function that you're replacing with 2. It can mean that for your division as well. So make sure you understand there's more than one way to write these notations. So go back through all of these examples and pay attention to the notations so that you don't get confused whenever, like you might see something written like this, or sometimes you might see it written like this. It means the same thing. So please make sure you understand that. All right. Thumbs up, subscribe. Thank you.